Hey kiddos, welcome back. We have just learned how to draw dot pictures, and I want to redraw some of those we've just drawn. So let's start with hydrogen, lithium, sodium, and potassium. So if you look at your dot picture for hydrogen, it had one dot. If you looked at your dot picture for lithium, it had one dot. If you looked at your dot picture for sodium, it had one dot. And potassium had one dot. All of those have one dot. If you look back at your dot pictures, they all have one valence electron. Let's take a look and see where they're located in the periodic table, shall we? Well, let's see. It looks like hydrogen, kiddos, is right here. Lithium, sodium, and potassium. If you recall, they all had one dot. They're in group number 1. Remember, of course, the last digit in the group number for the main group elements tells us how many valence electrons they have. So if I asked you about rubidium, cesium, or francium, of course you would tell me that their dot pictures would all have one dot. Okay? All right, let's look at the next ones that I'd like you to do. So now we have beryllium, magnesium, and calcium. So if you look at your dot pictures for beryllium, magnesium, and calcium, beryllium had one pair, magnesium had one pair, and calcium had one pair. Now let's take a look and see where they are on the periodic table, shall we? So if we look for beryllium, magnesium, and calcium, you'll see that here's beryllium, here's magnesium and calcium, and you drew one pair of electrons for each of those. What if I asked you about strontium, barium, or radium? Yeah, you'd say, that's easy, Mr. Hummer. They're in group 2. They all have 2 valence electrons, and we know the first 2 electrons are all paired up. All right, let's continue on, shall we? So let's take a look at fluorine, chlorine, and bromine's dot picture. Okay, fluorine, chlorine, and bromine's dot picture. So they're all the way over in group 17. So we know fluorine has 7 dots, 3 pairs and 1 unpaired. And chlorine has 7 dots, and bromine has 7 dots. Let's find them on the periodic table, shall we? So we look at the periodic table, and we find fluorine, chlorine, bromine, and well, we'll do a few others. You'll see that they're located here. They all have 7 dots, kiddos. All of them do. And what if I asked you about iodine and astatine? Yeah, they're in group 17. They all have 7 valence electrons, so we'd expect iodine and astatine also to have 7 dots in their dot picture. Well, that's pretty easy, isn't it? All right, let's go back and look at our notes again. And this time, let's look at neon, argon, and krypton. So if you find their dot pictures, you'll notice that they all have 4 pairs of valence electrons, or 8 valence electrons. They all look just like that. Well, let's find them on the periodic table, shall we? So, here we go, let's find them. We have neon, argon, and krypton. Should be able to do that. Here's neon, here's argon, and here's krypton. And sure enough, they have, of course, 8 dots or 4 pairs of valence electrons. Remember, that's stable. Shouldn't surprise you that they're in group 18, when xenon and radon also have 4 pairs of valence electrons. What about helium? Do you remember what its dot picture is? Yeah, it only has 2 electrons total, kiddos, so it is the exception in group 18. It just has 1 pair of valence electrons because it only has 1 energy level. Well, I would suspect that I could give the dot picture for just about any element on the periodic table, at least if it's in a main group element, just based upon its group number. Yeah, so if I went to group 13 over here, I would expect boron to have 3 dots, so 1 pair and 1 by itself. Aluminum, the same thing. Gallium, the same thing. Indium, the same thing. And thallium, the same thing. Let's pick another group. Let's pick group 15. So we'd have 5 dots, 1, 2, and then remember these other 3 are unpaired. Phosphorus, the same dot picture. Antimony, the same dot picture. Bismuth, the same dot picture. So if we know what family they're in, we should be able to draw their dot picture. Now we've sort of ignored these elements here. These are called transition elements, or what we call D block elements. And for the most part, they will have 2 valence electrons. But for this particular class, we really don't worry about why they have 2 valence electrons, and we usually don't draw their dot pictures unless I do them for you. So don't worry too much about those, or for these down here in what we call the F block. All right, well, let's go back to our notes and see where we are. And it looks like I want you to draw the dot pictures for rubidium, barium, astatine, and radon. So why don't you find them on your periodic table and go ahead and draw them in the space below. I'm going to give you a few minutes to look at your periodic table, find them, and then figure out what their dot pictures would be. So go ahead and pause your video right now, and when you're ready, press play and we'll see how you did. All right, welcome back. And so for rubidium, kiddos, you recognize that rubidium's in group number 1, it's atomic number 37, so 1 dot. Barium's in group number 2, it's atomic number 56, it has a pair of valence electrons. Astatine is atomic number 85, it's at the bottom of group 17, so it has 7 valence electrons. So I hope your dot picture looks something like that. And then radon is atomic number 86. It's at the bottom of group 18, so we would expect 4 pairs of valence electrons. So you should be able to draw the dot picture of any of the main group elements. That's groups 1, 2, or 13 through 18, just by finding its position on the periodic table. So a little profundity here. That means it's sort of kind of important. It's a profound statement here. So members of the same group or family, remember we call them families because they are similar to each other. They have similar chemical and similar physical properties. This was discovered by the Russian scientist Dmitry Mendeleev, and it led to the formation of the first periodic table. And we talk more about that in the next section of our notes. So, if I asked you which elements were similar to calcium, wouldn't you find calcium on the periodic table? And you'd notice that it's in group number 2. So what elements would be similar to calcium? Yeah, all of the other elements in group number 2. So beryllium, magnesium, strontium, barium, and radium. So why don't you take a minute now and tell me what elements you think would be similar to sulfur and sodium and fluorine. So pause the video, find them on your periodic table, and just write down all of the elements you think that would be similar to them. Okay? See you in a sec. Okay, welcome back. So sulfur is in group 16, so is oxygen, isn't it? So is selenium, so is tellurium, and so is polonium. Sodium is in group number 1, so you'd expect hydrogen to react similarly and have similar physical properties as sodium. Lithium, potassium, rubidium, cesium, and francium would all have similar physical and chemical properties. They're in the same family, kiddos. They're similar to each other. Fluorine is in group 17. So the other members of group 17 are chlorine, bromine, iodine, and astatine. Now, some of these families actually have family names. So for instance, group number 1, the metals in group number 1 are called the alkali metals. Now that doesn't include hydrogen. It's not considered to be a metal. The family name for group number 2 are called the alkaline earth metals. Group 17, these are called the halogens. Maybe you've heard that name before. And the family name for group 18, they are all called the noble gases. I bet you've heard that name before. Okay? All right, kiddos. We'll talk more about the periodic table in a later video and more about Dmitri Mendeleev. All right, talk to you soon. Bye-bye.